Hello everyone, welcome to my channel. Today we'll be discussing some new other important problems from chapter 4 of Zweifel and Nantz book. Okay, now let's begin. So in this question, the final product formed is this one. So now let's see how this product is formed with correct mechanisms. Okay. First of all, NaH is given and we know and one equivalent is given. Okay, so NaH is a strong base. Okay, so it will abstract the acidic hydrogen. Now in both the cases the two hydrogens are in same environment. Okay, so let us consider this hydrogen is abstracted first. Okay, this hydrogen abstracted and the negative charge is over the oxygen atom. Then the negative charge which will be in the oxygen atom is going to attack in the silicon. Let me show you the structure of this TbSCl. So TbSCl is tart, butyl, silyl, dimethyl chloride. Okay, this is the structure of TbSCl. The negative charge over here is going to attack here since oxygen has high good affinity for silicon and chlorine will leave. So we get the product from one is OH and this one O. Let me write in the short form only TbS. Further, on treatment with dead PPH3, we know this is a reagent name reaction. It is Mitsunobu reaction. Okay, it is Mitsunobu reaction. Now see how the reaction proceeds here with mechanism. Okay, so dead is diethyl azo dicarboxylate. Azo dicarboxylate. Sorry, C double bond O CO ET diethyl azo dicarboxylate, and also PPH3 is given. First of all, the lone pair in phosphorus is going to attack the nitrogen atom. Then there will be generation of negative charge over here, and this negative charge is stable. The negative charge which is going to generate here is stable because it is electronegative and also it can undergo in conjugation. Then this negative charge is going to abstract this proton and it will here becomes O minus and we get OTBS and here will be O minus and this will form ETO C double bond O NH single bond and PPH3 and there will be a positive charge in it and C double bond O OET. And in the next step, now we know oxygen has good affinity towards phosphorus. Okay, so it is going to attack in the phosphorus positive charge and this will leave and this group is going to leave. Okay, and we get the product as O PPH3 positive charge and here O TBS. Okay, and here is in double bond. Now the nucleophile given to us is pH COOH. Now any nucleophile can attack here, okay, because it became a good living group now. So the lone pair over oxygen atom is going to attack here. Now since it is below the plane, so it is going to attack above the plane and this group is going to leave. Okay, is going to leave as O double bond PPH3 and the product we are going to get is above the plane O C double bond O pH and here now let me in the full silicon tertiary butyl. So this is the product formed here. Okay, then in the next step it has been given lithium aluminum tetrahydride. So what is the function of this? It is going to convert it into alcohol. Okay, so there will be formation of alcohol and this group will remain as such. Now in the final step there is N tetrabutyl ammonium fluoride. So it can be written as N plus F minus. Okay, so we know fluoride has good affinity towards silicon, so it is going to attack silicon, and this bond will break, and here negative charge will be generated. And since tetrahydrofuran is given, so it is going to abstract the negative charge which will be generated here is going to abstract a proton from the solution, and thus we get the final product here, and thus we are going to get this final product. Now let's move on to the next question. In this reaction, the following product this is formed, and it has been shown the stereochemistry. Okay, for that we have to write the chair form of the cyclohexane ring configuration. Okay, now in the cyclohexane, where will I put this methyl group? The methyl group is more favorable in the equatorial portion, right? So I'm putting it here, and double bond O ketone group here. Okay, now this one is a boron hydride compound. Okay, so what is its role? It gives hydride, it acts as a hydride donor. So from where the hydride is going to attack? It is from above the plane or below the plane? It cannot be from the above the plane, since two axial hydrogens are there. So due to axial interactions from this side, it is not possible. Okay, so the attack will be from below the plane. Okay, and this will negative charge will be in the oxygen atom. Further, the negative charge which will be in the oxygen atom is going to attack the tosyl group, and this chlorine is going to leave. So we get the product as, so this is going to be the product of this step. Okay, this is the product of this reaction. Then on addition of NaCN, what will it will give? NaCN means Na plus Cn minus. So now OTS is a very good leaving group, so attack will be from below the plane and OTS will leave, and we get the product as like this. Okay, synovial attack from it will be in the equatorial portion, and then LiAlH4 is added. So on addition of LiAlH4, since it is a hydride donor, so it will convert Cn to CH2 NH2. Okay, then what it becomes? So this will be the final product. Now we can write it like this, as since CH3 is below the plane, and this one is also below the plane, 1 2 3 1 2 3 below the plane, carbon is below the plane, CH2, and then NH2. So this is the final product we have got. Let's see another question. So what will be the product in this reaction? Let us see. First of all, Me2COMe whole 2 is given, so it acts as a protection of this one. It acts as a protection of 1,2 diol. Whenever you get a 1,2 diol, it gives protection of that group. So here in this case, there is COOH, and here OH, and carbon OH, and C double bond O. Here is 1 2, so there is 2 OH groups are there, so it is going to get protection from Me2 OMe. So first of all, we can consider like this easy way. The lone pair on the oxygen atom is going to here, and OMe is a good leaving group, it will leave. Again this oxygen is going to attack here, and OMe is a good leaving group, right? So it will give us OCO, and we will get this product in the first step. Okay, now let's see what is in the second step. In the next step, BH3 is added, okay, along with tetrahydrofuran. We know BH3 selectively reduces carboxylic acid to alcohol. Okay, so we get the product as it will reduce it to alcohol, and there is a C double bond O, 2 methyl groups are here. Further, in the third step, we have been given IPR2NET. It is a base. Okay, it is base, so it is going to abstract this proton is going to abstract this proton, and a negative charge will be generated in the oxygen. Okay, and then there is a possibility of forming a 5-membered ring. 1 2 3 4 5. Okay, so this negative charge is going to attack here. The charge will go up and it will come back, and then this bond will break. Okay, and negative charge will be generated here. Okay, so we get as like this. Okay, so there is the oxygen, there is O minus, and there is 2 for the methyl group. Then the next step is this oxygen, this negative charge will come here, and there will be this bond will break, and again the negative charge will be here. Okay, further BOMCl is also given, and BOMCl is, let me draw the structure first. BOMCl stands for benzyl chloromethyl ether. Okay, so the next step is easy. This negative charge is again going to attack here, and chlorine is a good leaving group, so it will leave, and thus the product forms as, so oxygen and BOM I am writing in the short form, and here is carbonyl. So this will be the final product of this reaction. Now let's see our next question. So in this reaction the final product formed is this one. Now let's see how this product is formed. First of all, acetone is used in presence of catalyst tosyl hydroxide. The function of acetone is that it is used for the protection of 1,3-diol. Okay, 1,3-diol protection. Okay, so in this case, where is 1,3? 1, 2 and 3. Okay, used for the protection of 1,3-diol. So the product formed here is, so this is the product formed in the first step. Okay, protection of the 1,3-diol. And then NaClO2, that is sodium chloride, not chloride, it is chloride. Okay, in presence of sodium dihydrogen phosphate and tertiary butanol, it acts as an oxidizing agent. Okay, it then oxidizes the primary alcohol to carboxylic acid, and we get the product as, and we are going to get this product. Okay, then on addition of SOCl2, it is simple. SOCl2, I am representing this group as R, and SOCl2 means when we attack RCOCOH, then it gives RCOCl, right? Then again ammonia is added. So what it will do, the lone pair over nitrogen is going to attack in the carbonyl carbon, the bond will go here, come back, and chloride is a good leaving group, so we get it RCONH2. One hydrogen was there, but it will neutralize the positive charge here. Okay, and we will get RCONH2. Then on addition of lithium aluminum hydride, what will be the product? Since it is a hydride donor, and also in this case it will give us RCH2NH2 as the product. Okay, that is lithium aluminum hydride will reduce the amide to primary amine, and thus we get our final product.